This video is going to run through operations with fractions. Let's start by reviewing how we reduce or put fractions in lowest terms. The basic idea is if we want to reduce a fraction like I have here on the screen, 48 over 64, we have to find common factors, numbers that we can divide out of both the top and the bottom. One way to do that is to create a list of all of the prime factors of both the numerator, number on top, and the denominator, number on the bottom. So 48 is 4 times 12, and I can break those numbers down more because 4 is 2 times 2, 12 is 3 times 4, and we can go a little bit further. This 4 is 2 times 2. We can do the same thing with 64. 64 is 8 times 8. Each of those 8s would be 4 times 2. And then we can break down those 4s into 2 times 2. So the numerator, the 48, is 2 times 2 times 2 times 2 times 3. And that's what I have written down over here in blue. The numerator, 4 2s and a 3. 64 is 2 times 2 times 2 times 2 times 2 times 2. That's a total of 6 2's being multiplied together. Once I write out all the factors, then I can just cancel out common factors, factors that are the same. The idea is if you look at this fraction, 2 divided by 2 turns into a 1, and so we can just cancel those numbers out. And we can do that with all of the common factors, and then we're just left with a 3 on the top and 2 times 2, or 4, on the bottom. So this fraction reduces down to 3/4. Now this is kind of a long method, but it always works. It'll always give you your lowest terms or your simplest form. There is another way to do this problem. Sometimes when I look at the fraction, same example, 48 over 64, I just know what a common factor is, just by thinking about the times table. So for example, I notice that both 48 and 64 are divisible by 8. 48 divided by 8 is 6. 64 divided by 8 is 8. So I can divide both the top and bottom by 8. And then I just have to keep going until there are no more common factors. 6 and 8 are both even numbers, so we can divide both of those by 2. That gives us 3 over 4, which is the exact same answer we got before. This reduces down to 3/4. All right, before we move into the operations, a little bit more vocabulary. What I have on the screen right now, 10/3, is called an improper fraction because the numerator is bigger than the denominator. When we have improper fractions, we can also write them as mixed numbers. And the way to do that is just by dividing. 3 goes into 10. 3 goes into 10 3 times. 3 times 3 is 9, with 1 left over. So this becomes 3. That's the quotient. It goes in 3 times, with 1 left over. So 3 and 1/3. If we want to go in the other direction, write as an improper fraction, to kind of do that operation backwards, we can take 4 times 5. 4 times 5 is 20, and then you add it to the number on top here, to 2. So 4 times 5 is 20, plus 2 is 22. So 4 and 2/5 is 22/5. All right, so now let's run through our basic operations with fractions. If we want to add or subtract fractions, we have to have the same denominator. Always have to have the same denominator. 5/12 minus 7/12, we have the same denominator. That's a good thing. And so then we just add or subtract the numerators, and the denominator stays the same. So to solve this problem, we would take 5 minus 7, and then the denominator is going to stay as 12. 5 minus 7 is -2. so negative 2 over 12. And then I'm going to reduce this fraction. 2 and 12 are both divisible by 2. And so this becomes negative 1/6. I am going to put the negative in front of the fraction. If you have a negative on either the numerator or the denominator, you can just put that in front. It goes back to that idea that if you take a negative divided by a positive, you get a negative. All right, so what if the denominators are different? Well, then we have to find a common denominator. We always need a common denominator to add or subtract fractions. So one way to find the least common denominator is to take the denominators that you have and create factoring trees. Find all their prime factors. So I'll start with the 8. 8 is 4 times 2, and we can break that 4 down into 2 times 2. 20 is 4 times 5, and I can break that 4 down into 2 times 2. Then the idea is my LCD has to contain every single factor from both denominators. So I start by looking at the first denominator, the 8, and I just write down all 3 2's. So 8 is 2 times 2 times 2. That goes in my LCD. Then I move over to the 20, and any numbers that are already written down in my LCD list, I don't have to include. So I notice that I already have 2 2's written down. And so all I'm going to need to include or tack on is that 5. And so now my LCD contains the 3 2's for the 8, and it contains 2 2's and a 5 for the 20. If I multiply those numbers together, I should get 40. So my LCD is 40. The next step is we have to rewrite each fraction with a denominator of 40. So 3/8 and 3/20, we need to change those denominators to 40. So how do I turn an 8 into a 40? Well, I have to multiply by 5. I'm going to do that to both the top and the bottom of my fraction, so the value of that remains unchanged. So 5 times 8 is 40, and then I'll take 5 times 3 to give me 15. Okay, 3/20 to turn a 20 into a 40, I got to times by 2. So I do the same to the top. 2 times 3 is 6. And now my problem is 15/40 plus 6/40. To add, we add the numerators. 15 plus 6 is 21, and the denominator stays the same. So final answer is 21/40. The same idea is true with subtraction. So let's do another example. 1/9 minus 2/15. 9 is 3 times 3. 15 is 3 times 5. So my LCD has to contain the 2 3's from the 9, and then it has to contain a 3 and a 5 for the 15. We already have that 3 written down, so we only need to tack on the 5. 3 times 3 times 5 is 45. All right, so both fractions need a denominator of 45. To turn a 9 into a 45, I've got to multiply by 5. So do that to the top as well. That's 5 over 45. To turn a 15 into a 45, we have to multiply by 3. So I'll do that to the top and bottom, and that gives me 6 over 45. Now that we have the same denominator, we can subtract the numerators. 5 minus 6 is -1, and the denominator stays at a 45. So final answer would be -1 over 45. If we want to add or subtract mixed numbers, one way to do that is just to rewrite these as improper fractions and then do the exact same math we did before. So let's see, 2 times 4 is 8, plus 3 is 11. So 2 3/4 turns into 11/4. 4 times 2 is 8, plus 1 is 9. So 4 1/2 is 9/2. So this problem has become 11/4 minus 9/2. I need to get a common denominator. And in this case, I notice, just because the numbers are a little bit smaller, I can kind of see by looking at it, I can turn this 2 in the second fraction into a 4 if I just multiply by 2. So I'll do that to the top and bottom. And 9/2 turns into 18/4. So 11/4 minus 18/4. 11 minus 18 is -7. Denominator stays a 4. So -7/4 is my answer. And in many cases, you can just stop there. But if the directions want a mixed number, then we could take this a step further. 4 goes into 7 just one time with a remainder of 3. So this turns into -1 3/4. All right, so to add or subtract, you always need a common denominator. If you want to multiply or divide fractions, you don't need the same denominator. Instead, we can multiply by simply going straight across. That means if I have 7/20 times 4/5, I can just multiply 7 times 4 is 28. 20 times 5 is 100. So I just multiply straight across numerator times numerator, denominator times denominator. And then I do have to reduce. I notice that both 28 and 100 are divisible by 4, and that gives me 7/25. Now it turns out you can actually do the reducing before you multiply. And when the numbers get a little bit larger, I actually think it's a lot easier to reduce before you multiply. So same problem, 7/20 times 4/5. I notice that the 4 and the 20 have a common factor of 4. 4 divided by 4 is 1. 20 divided by 4 is 5. Now if I multiply straight across, 7 times 1 is 7. 5 times 5 is 25, and I get the exact same answer, 7/25. If you want to divide fractions, that key to that is to turn it into a multiplication problem. Division is the same as multiplying by the reciprocal. And this word reciprocal simply means you take the fraction and you flip it. So to solve a division problem, the first fraction stays the same. Copy down the first fraction. Division turns into multiplication, a dot. And we flip or take the reciprocal of the second fraction. Some people remember this division by saying copy, dot, flip. Copy the first, change to multiplication, flip the second. But really the idea is division means multiplying by the reciprocal. And now we can just multiply straight across, or we can try to reduce first. Let's see, 5 and 15 are both divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. And then 4 and 6 are both divisible by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And now we go straight across. We have a negative times a positive, so negative. 2 times 1 is 2. 3 times 3 is 9. Final answer, -2/9. All right, here's one more. 2 and 1/6 divided by 1 1/3. Now to solve this division problem, we have to change these into improper fractions. So 2 times 6 is 12, plus 1 gives me 13. So 13/6. 1 times 3 is 4. No, I said that wrong, didn't I? 1 times 3 is 3. Plus 1 gives me 4. So 1 1/3 is 4/3. And now this problem is a lot like the one we just did. To turn it into a multiplication problem, copy, dot, flip. Copy down the first fraction, change to multiplication, flip the second fraction. We can go straight across, or I notice that 3 and 6 are both divisible by 3. 3 divided by 3 is 1, 6 divided by 3 is 2, and now if I go straight across, I get 13 times 1 is 13, and 2 times 4 is 8. So 13/8 is my answer. Now, frequently when problems start with mixed numbers, we're asked to put our answers back as mixed numbers. So let's see, 8 goes into 13 only one time, with 5 left over. So 13/8 is 1 5/8. Now we can also apply our order of operations to problems with fractions. If I want to evaluate 1/2 times 1/3 minus 3/4 squared, I can use my PEMDAS. So I'm going to start by dealing with this exponent. 3/4 squared means 3/4 times 3/4. If I multiply straight across, 3 times 3 is 9, 4 times 4 is 16. So 3/4 squared is 9 over 16. Now we have 1/2 minus 1/3, or no, it's 1/2 times 1/3 minus 9/16. Continuing with PEMDAS, we have to multiply before we can add or subtract. So 1/2 times 1/3, just go straight across, would be 1 over 6. So 1 over 6 minus 9 over 16. Finally, to do this subtraction, we need a common denominator. So let's see, 6 is 2 times 3, 16 is 4 times 4, and each of those 4s can be broken down to 2 times 2. So my LCD needs to contain the 2 and the 3 from the 6, but then since I have 1 2 down, I don't need to add the first 2 in my 16, but I will need to add the other 3. And so my LCD, again, it has the 2 and the 3 from the 6, and then it has to have a total of 4 2s in it. So 2 times 3 times 2 times 2 times 2 should be 48. So if I want to turn 6 into 48, I got to multiply by 8, top and bottom. If I want to turn 16 into 48, I have to multiply by 3, top and bottom. So now I've got 8 over 48 minus 27 over 48. To finish, we subtract the numerators. 8 minus 27 is negative 19, and the denominator stays the same. So final answer would be negative 19 over 48. That was my last example. As always, please reach out if anything from this video is unclear.